So today we are going to be talking about properties of quadrilaterals. Remember that quadrilateral means a four-sided shape. These are definitions that you're going to need for all of next week as well. So make sure that you have these in a safe place because you're going to really be using these and looking at them a lot. As always, if you are in class with me while we do this, I will pause and let you write down the words and the definitions and draw the shapes. If you are watching this from home, you need to do that on your own. So you need to have the word, the definition, and the shape or shapes. So the first word is a parallelogram. So a parallelogram is really a parallel. Okay, keep in mind parallel means two lines that never meet, right? So parallelogram, the definition is both pairs of opposite sides are parallel and equal in length. So when I look at this rhombus here, the top and the bottom never meet. The sides never meet. But also the top and the bottom are equal and the sides are equal length. Same thing for a square. In all three of these shapes, the top and the bottom will never meet, and neither will the sides. If I continue the lines on, they will never meet. Whoops. And in a square, we know that all sides are the same, so definitely the top and the bottom are equal and the sides are equal. And then in this rectangle, I can see that the top and the bottom are equal length and the sides are equal length. Then we have a trapezoid. A trapezoid, only one pair of parallel sides. Okay, so notice it doesn't say anything about side lengths. About the lengths of the sides. It doesn't matter. For a trapezoid, we're only looking to see whether there's parallel lines or not. So in this shape, this rhombus type shape, well, not a rhombus, it's a trapezoid, because if it's a trapezoid, it can't be a rhombus. In this first trapezoid, I can see that the top and the bottom and the two sides are parallel. Okay, I'm so sorry, I am totally messing up this word. They only have one pair of parallel sides. The top and the bottom on this first one are parallel. But if I continue on with these two side lengths, eventually they would meet in kind of a triangle. Okay, so only one pair of side is parallel. Same thing over here on this shape. And actually, I don't even know about that shape because it's kind of hard to tell. I think I would have to actually get out my protractor to measure and see some of those angles to see if that's really parallel. So don't draw the second one, but draw this first shape. Then we have a rectangle. Now, the definition of a rectangle is a parallelogram with four right angles. I italicized parallelogram for a reason, okay? Whatever the definition says for parallelogram has to be true, plus it has four right angles. So I'm going to go back to that definition of a parallelogram, okay? Remember, a parallelogram says both pairs of sides are parallel and equal. Okay? So that means that over here, both pairs have to be parallel and they have to be equal length. Okay? Plus, in order to be a rectangle, it has to have four right angles. Okay? Now, some people say, oh, but Miss Higby, yeah, I see this first shape is a rectangle, but that's a square. That's not a rectangle. Well, technically, this shape is a rectangle. Yes, it is also a square, but it's a rectangle because it meets the whole definition of a rectangle. And that's something we're going to talk about today. Then I have a rhombus. Okay, again, a parallelogram. So both pairs of opposite sides are parallel and equal. Okay, has to fit this definition. Plus, all sides have to have the same length. Okay, so look at this. Yes, I know this is a square, but it's also a rhombus because it's a parallelogram and all sides are the same length. Okay, now I made sure to put these first two rhombi in there because I wanted you to understand, because sometimes students tell me that a shape is a rhombus if it's tilted in one direction, but if it's tilted in another direction, they think that it's not that same shape. But it is. Okay? So it doesn't matter which way the shape is rotated, it's still going to be a rhombus because it still fits that definition. And finally, we have a square. A square, the definition for that is it has to be a rectangle first. Okay? It has to meet that definition. So it has to be, oh, look at that. So it has to be this. So both pairs of sides are parallel and equal. It has to have 4 right angles. And all sides are the same length. Okay? So a square has a lot of names. It's not just a square, it's a parallelogram, and it's a rhombus, and it's a rectangle. So it has a lot of definitions, okay? A lot of names for this word, for this shape. So now we're going to use all of those definitions to help us start talking about whether shapes are, like, what's the most specific name possible. Okay, so yes, I just said that a square has all those other names, right? But its most specific name is a square. And so when I look at that shape, I want to call it a square, even though, yes, it is a rhombus, it is a rectangle, and it is also a parallelogram. Okay, I can also call it a quadrilateral, and I can call it a polygon, okay, because all those names are true. But if I'm talking about this specific shape, I want to call it a square.